Alright, so in this video we're going to look at the imaginary unit, I, and complex numbers, and simplifying complex numbers. So the imaginary unit by definition is equal to the square root of -1. So if we want to simplify the square root of -12, we can think of that as the square root of 4 times the square root of 3 times the square root of -1. So the square root of 4 is 2, so 2 square root of 3i. Now, a lot of times instructors won't want you to put the I in the back like I have done here, so they'll ask you to put it in the front. You kind of think of when you kind of break down variable expressions, put the variable in the front there, and that's fine. It just, there's reasons, and I'll show you in the next screen why I like the I in the back, but it's up to you which way you want to use it. So let's look at some powers of this imaginary unit. So let's say I take I to the first power. Well, that's I. I squared, well, anytime you square a square root, you get the value inside, so we get -1. I to the third, well, that's I squared times I, so -1 times I is -I. I to the fourth, well, that's I squared times I squared, so -1. I to the fifth, well, that's just I to the fourth times I, so 1 times I is I. I to the sixth is I squared times I to the fourth, so 1 times -1 is -1. I to the seventh, I to the fourth times I to the third, so 1 times -I is -I. I to the eighth is I to the fourth times I to the fourth, so 1 times 1 is 1. And what we see is this goes through this cycle of 4. Every time you hit a multiple of 4, it goes back to 1 and the cycle resets. So we can use that to simplify expressions. Let's say I had I to the 235th power. Well, what I'd want to ask myself is, what's the largest multiple of 4 less than or equal to 235? The answer is 232. So this is the same as I to the 232nd power times I to the third. Well, I to the 232nd power, since that's a multiple of 4, that's 1. I to the third power is -I, so 1 times -I. So I to the 235th power is -I. What if you have negative exponents? Well, you can kind of use this in reverse. You can say, well, I to the -6 is the same as 1 times I to the -6. Well, remember, any multiple of I to any multiple of 4 is the same as 1. So what I want to do is I want to pick a multiple of 4 that is bigger than the absolute value of -6. So I'm going to pick I to the 8th. I to the 8th is same as 1. Now I can use those rules of exponents that say you can add the powers when you have the same base. So this is I to the second, which is -1. So you can basically just keep adding multiple 4 until you get into a positive exponent, and then figure out what that is. Alright, so this brings us to the biggest set of numbers we're going to see, the complex numbers. And complex numbers are numbers that fit this format. A plus bi, where A and B are elements of the real numbers. So some examples of complex numbers. 3 plus 5i, that's a complex number. 7 minus 4i, that's a complex number. It fits that pattern because when we say 7 minus 4i, what we're really saying is 7 plus -4i. So -4 is a real number, so that does fit the pattern. Square root of 5 plus pi, yes, this doesn't say these have to be rational numbers. Square root of 5 and pi are both irrational numbers, but they are both real numbers, so this would still fit that pattern. You can even have something as ugly as this, 2 minus 3 square root of 7 plus 4 plus square root of 2 quantity I. Basically, the first parenthesis is 2 more than -3 square root of 7, and the second one is 4 more than the square root of 2. Those are numbers. Those are real numbers. They're irrational numbers, but they are real numbers. So it still fits that A plus BI format. 6i, does it fit that pattern? Well, yes, it does. When we say 6i, what we really mean is 0 plus 6i. So the 0 is a real number, therefore it fits the pattern. So 6i fits that pattern. What about 14? Well, yes, it also fits that pattern. 14 is really 14 plus 0i. What that means is any number you've seen in your life has probably been a complex number. And this has two parts. This has the real part, the A part, and the imaginary part, the BI part. So when we talk about real numbers, what we're talking about is complex numbers where the imaginary part is 0. When we're talking about imaginary numbers, we're talking about complex numbers where the real part is 0. But both of those, all of those numbers are complex numbers. Another concept, basic concept, before we get too far into doing any simplifying expressions, is the idea of the complex conjugate. The complex conjugate of a number is a new number that is just like the old one, except the imaginary part is opposite. So here's a table of some various complex numbers and their complex conjugates, and realize that the complex conjugate works both ways. So, you know, the number on the top is the complex conjugate of the number on the bottom number is the complex conjugate of the number on top. So negative 3 plus 2i is complex conjugate, negative 3 minus 2i. 5 plus minus 4i is complex conjugate, 5 plus 4i. 6i, again, remember that up above I said 6i was a complex number, so its complex conjugate is negative 6i. Again, the imaginary part changes signs. 14, we said, is a complex number above, so its complex conjugate is also 14. You can think of that as 14 plus 0i and 14 minus 0i. In both cases, 0i, so we don't bother to write it, but those are the complex conjugates of them. All right, so let's look at putting these together. Let's say I want to add or subtract complex numbers. And we have something as simple as this, 3 minus 4i minus 6 plus 2i. So pretend like these are not square roots of negative 1, but they're just some kind of weird variable, this I variable. How would we do this? Well, what we would do is we would distribute, and then we would combine like terms. So we'd rearrange these, get the constants together, the I parts together. And the only big difference is, you know, usually we write variables in the front, whereas we're writing this I in the back. So it fits that A plus BI format, or in this case, A minus BI format. But, you know, the approach, this is a complex numbers, you just combine like terms. That's all it is. So that's the great thing, since every number we've worked with has been a complex number, these properties are going to overlap with things we already know. Something like this, again, I can't just start adding these. What I need to do is I need to, just with the regular roots, I need to break these down. So square root of negative 18, that's 9 times 2 times negative 1. Square root of 9 is 3. Square root of negative 1 is I, so 3i square root of 2. 50, 25 times 2, and then you have the negative inside, so that's an I, so 25 times 2, 5 root 2. And then we're just going to combine like terms. 5 minus 3 is 2. 3 minus 5, 3i root 2 minus 5i root 2 is negative 2i root 2. Say you had something like this, and we're going to break it down. So 4 times 3, so 2 root 3. Negative 75, root of that is 25 times 3, so negative, square root of 25 is 5, so times that 2 is is 10i root 3, and then negative 45, that root is 9 times 5 times the I, so 9 is 3i root 5. And we also want to distribute that negative sign, so negative 4, and negative, so we make that positive 3i. And then what are we going to do here? Well, none of these are like terms. None of them match perfectly. You know, like if you look at the first two, they both have root 3s, but one has an I and one doesn't. And you look at the second and fourth one, they both have I's, but they don't have the same roots. Well, what do we do in that case? Well, we get the parts without the I's together, we get the parts with the I's together, and we group them up, and we factor out that I. And so this fits that format, A plus BI, as much as we can get it to look like. That's what we're trying to get the answer to look like in the end. Multiplying complex numbers. So let's say I want to take negative 2 root negative 6 times 5 root negative 15. Well, the little trick here is you have to make the i's come out first. Now, if you can break down the square root of 6, great. If you can break down the square root of 15, okay. But you don't have to do that. But you do need to say, oh, if I have a negative under those roots, that means I have i's. Then I'm going to do front times front and inside times inside. Negative 10, I times I is I squared. Square root of 6 times 15 is 90. And then I'm going to break this out. Well, I squared is negative 1. 90 is 9 times 10. So square root of 9 times square root of 10. So negative 1, square root of 9 is 3, and then just clean it up. Negative 10 times negative 1 times 3, positive 30 root 10. So the trick here is you have to make the I show up when you're doing multiplying by complex numbers. A lot of times the problems will look more like this, in which case what we're going to do is we're just going to distribute this out, FOIL it out, you might say. And so, 12, 6i, negative 20i, negative 10, I squared. Again, I squared is negative 1, so negative 10 times negative 1 is positive 10. And then combine like terms. 12 and 10 make 22. Positive 6, negative 20 make negative 14i. And again, it looks like that format. A plus bi or a minus bi or one above, just a, just a real number. Sometimes that. Alright, so, maybe this is kind of like in the middle. You gotta do some simplifying first. Break down the square root of negative 12. Break down the square root of negative 48. There's going to be i's on both of those. And again, you wouldn't necessarily have to break down 12 and 48, but we might want to go ahead and just make it easier to work with here. So 4 times 3, so 2 square root of 3, 16 times 3, 4 square root of 3. And then we're just going to FOIL that out. So 4 times 8 is 32, 4 times 4i root 3 is positive 16i root 3, negative 2i times 8, negative 16i root 3, and then negative 2i, positive 4i, negative 8i squared times the square root of 9, 3 times 3. Square root of 9 is 3, I squared is negative 1. So on that last term, it's going to be negative 8 times negative 1 times 3. So positive 24. And those middle two terms are going to cancel out. And we're going to get 32 plus 24, 56. So you can get real numbers as answers by multiplying two complex numbers. It can happen. All right, dividing. Dividing's a little trickier. Just keep in mind that I, by definition, is the square root of negative 1. So technically, while we're talking about i's, we kind of get away from that a little bit. But it's important to realize that that means if you have an I in the denominator, you have a square root in the denominator, and we don't like roots in the denominator. So we need to fix that. So the 2 isn't the problem here, it's the I. So what we're going to do is we're going to multiply top and bottom by an I. That will give us I squared on the bottom, which is negative 1, which is a real number. So no more i's on the bottom. We do need to distribute that I to the top, so 6i minus 3i squared. And again, I squareds are negative 1, so that's going to become a negative 3 times negative 1, so positive 3. That's make negative 2. And then what we're going to do is split this into two fractions. And we're going to have the real part, so in this case, the 3 over negative 2. And the imaginary part, 6i over negative 2. And then we're just going to simplify that. So negative 3 halves minus 3i. 6 divided by negative 2 is negative 3. What if we have two terms in the denominator? Well, what we're going to do is just like with radicals, we multiply top and bottom by the conjugate. We're going to multiply top and bottom by the complex conjugate. And again, the complex conjugate just means change the sign of the imaginary part. And so you're just going to distribute that out, top and bottom. Again, the bottom ones are going to cancel out in the middle because what you're setting up is the difference of squares, except this is going to be negative 25 times negative 1. So it's actually going to come out to be the sum of squares on the bottom. You're going to get 29. Again, I squared is negative 1, so 20 on top times negative 1, negative 20. Combine like terms. And you get negative 14 on top, negative 14 plus 23i on top over 29. And again, you can't stop here. You got to split it into two parts. So you got an A and a B. A clear A, a clear B. So the final answer, negative 14 over 29 plus 23 over 29.